Okay, we'll go ahead and get started. Thank you, everybody, for joining our webinar. My name is Nguyen, and I am the Division Manager for Terrestrial Laser Scanning here at RIEGL USA. We'll go ahead and just go over the agenda. I promise I won't take too long, but let's look at the content. So we have some new additional camera solution, right? It was a big push for from our customers to make it an internal camera, and of course we did that, and we answered it with 3 internal cameras on the VZ600i, but we also have other solutions too as well. And then we'll go over the onboard face detection and blurring. This is a technology that we implemented to hold privacy of individual when we're scanning out in the real world environment. And then also introducing a new type of targets, and this is very neat, very unique to our terrestrial line. In the past, we've always used reflective targets, but now we also introduce a different type of targets as well, and for different applications, which I'll emphasize a little bit later. And then some port shading and versus X-ray view, right? So this is just a very a realistic way to view data and to present data, and also to really showcase the point cloud in a very realistic point of view. And then a new plugin. So we've added plugins in the past, right? So we've always tried to make our software better with additional tools. I think our software has always been the bread and butter, has always been the registration, right? And that's really what we focus on, and automated processing. But now we've added tools because we've had high demands and support from research university, particularly in the forest industry. And so I think you'll like this new plugin. And then of course I want to showcase, since I received the VZ600i in my possession, I've had it for almost a year now, and this whole summer I've been doing a lot of scanning. So I want to put it through the real world, and I want to bench test it, and I want to really showcase the productivity. And then I think what we're going to show you is going to be really compelling. These are real world numbers, right? And I challenge anybody to take my numbers and either beat them or make them better, but I hope you can beat them. But they're pretty good. So let's go ahead and get started. Nope, too fast, sorry. All right, so internally we've added 3 internal cameras, right? So the reason why we needed 3, because the sensor in there are quite small. It's 12 megapixel sensors, and one is pointed at horizontal and up, and then down, and then when you stitch together, it makes that 100 to cover 105 degrees of view. And if you don't know, we recently extended the vertical view up to 5 degrees extra pointing up. So and that's really to take advantage of more indoor scanning in tight areas, right? So we've always had the so with the indoor with the internal camera, we also have an additional new to the product line is a RIEGL Z1 360-degree camera. So this is a 2-lens camera, and this is actually their flagship. So if you don't know this brand, they make very high-end 360-degree camera. This one particularly is their flagship camera, which has 23 megapixel, I believe, and also internal storage. But don't worry about that, because all the data is stored directly onto the scanner hard drive. So, and the interface is also, and the setting is also done through the scanner's interface too as well. So this is typically very good for indoor scanning in lower light condition, and provides a highly spherical 360-degree realistic image. So if you have a need for this for indoor mapping, take a look at this 360-degree camera, which is very nice and complements the VZ600 very well. And then of course, the external camera that we have, that we've always had on all of our generations of scanners, from the first generation all the way down to the newest one, which is the 600i model, is the Sony Alpha AR74, right? So this is a very high-end camera. It's proven in a photogrammetry or an aerial photogrammetry, unmanned programs to produce superior images along with the scanner. So all three of these camera options, please understand, the images are acquired at the same time, right? So as we're scanning and collecting the LiDAR, it's also taking images too as well. So for example, just to give you time, it takes approximately 25 seconds to complete a 360-degree scan, full scan, at 6 millimeter resolution at 10 meter range. 25 seconds. We like that number is because it's a very good resolution for most projects. When I say most, when you're talking about transportation, indoor, structural, bridges, and then also forestry too as well. So we really like that number. But of course, our system has always been a user-defined system. What that means is that we can extend the range by slowing down the pulse repetition rate. We can make it, we can even take a faster scan by reducing the resolution, and we can take a high resolution scan, and we can also reach out to 1,000 meters. So it's a very dynamic user-defined system. And with all these three camera options, you can switch them on at any given time with simply a 3 quick release screw. Okay, so let's move on. Here's the onboard face detection, and this is a very demanding stuff that we saw, right? So we were a lot of customers were asking, because now these days a lot of stuff is sensitive, people are sensitive. So this is a very good feature, and it's completely automatic, right? So we don't have to do any kind of thing. You just literally turn on. So our system, the VZS600i and the predecessor, have something called a workflow. So within the workflow, you define all your parameters from georeferencing to resolution to pulse repetition rate, which dictates the range. But also you can turn on and off the face detection with a simple touch of a click of a button. Yeah, and it's complete, and it also carries into the processing too as well. So it's from the images transfer over to the 3D point cloud, and then when you export the data, the face is also blurred out in the point cloud, either LES, E57, or whatever format you want to use. Yep. It also works on statues too as well. So you can see here is an example of a statue. So it's not biased to just people, right? So even if you have a picture on the wall, and if you're scanning in interior, it also detects face too as well. So it's a very unique feature that I think a lot of our customers are going to want to use. And I can see this happening when you're doing project where there's a lot of people around. People ask you, and when they do ask you, you can show them right there and then, right? So after you take a scan, you open up a picture, you can see their face being blurred out on the scanner. So there is no questions asked. Hey, are you taking my picture? You can say yes, but you're not going to be recognized at all. All right. So moving on to a new target. So in the past, historically, we've always used a highly reflective retro reflector, whether it's flat or cylindrical, no sphere. Okay, so we've only used flat or cylindrical. We've done some testing in the past with sphere, but in order to keep the most, in order to maintain the high accuracy of the target, because it didn't transfer down to the control, right? Because you use the targets to reference control. And we try to take out as much error as possible. So we've always had great success with the highly retro reflective targets. But now introducing a black and white checkerboard type target, our scan can also recognize this too as well. And I can see this being a very good option for indoor mapping, facility mapping, mapping out Walmart, Sam's Club, or Target. You can just place them there, and the scanner will recognize them. Also, if you don't know, the VZ600i and also the 400i, it also can be converted into a mobile system too as well. And that's something I'm going to give on a little bit later down the year when I do more testing, right? So this is a new feature for us that we implemented last year, same time last year. So the scanner itself internally has an IMU, has a differential GPS, so you can get correction from a VRS network. But now, when you're driving down the road, I can see you placing these targets, on the side of a building or maybe on a curb, and the scanner can then recognize the targets. But of course, that has to do with that has more to come with that, right? From testing that I want to be doing here in the next few months. So, and I'll do a webinar on that too as well. But yeah, new type of targets introduced to still existing our retroreflective cylindrical targets or flat targets. Okay, and of course you can define the type of targets you use, so we're not just biased and dedicated to one size, right? So if you're doing a project where you have long range, and our scanner can pick up targets, out to over 100 meters away. So keep that in mind too as well. So our scanner can detect targets at long range and also at short range. And when you're doing a project, the target doesn't have to be next to the scanner. It could be, further away. And this is great because you can define a target, a bigger target for longer range, if you want to place that at longer range. So you can define your target and make your own targets and customize your own targets as long as you implement the right attributes into the target parameters. You can use whatever size you want, I can say. Yeah. Okay, so let's look into some of the software. So as our hardware develops, of course, we also have to develop software too as well. And our software in the past, I've never been more impressed than ever, right? Mainly because it's completely automated now. In fact, I can process a point cloud right now without even looking at the data. I can register it, I can filter it out. I don't even need to look at the data anymore. It's completely automated, right? So it's a one-touch processing wizard that allows you to process the data from start until end, all the way up to deliverable, including views such as the point shading. And you'll see here, I'll show you a very compelling, wonderful picture here shortly. And then the X-ray, right? So the X-ray was added a couple of years ago. We loved it, right? It's a great way for visualization, especially for structures, indoor. You can see, and it outlines the X-ray view. A lot of people want me to explain. It really just highlights the edge of objects, right? So if you have a complex facility, like an indoor facility where it has multiple levels, you turn on the X-ray, you can see your stairs, you can see your elevator shaft, you can see your the outline of doors, buildings, office space. Really, and you can also measure from it too as well. Sometimes when you click on a point, you're not sure if you're clicking on, a corner of a building or an edge of a building. With the X-ray view, it outlines the, as you can see here on the X-ray view on the right-hand side, the curve is well defined, right? Because that's the edge of the object, and that's what the X-ray view is, right? And let's go ahead and take a look at what I mean by the point shading. Here we go. Yeah, there we go. Beautiful structure, right? So this is great for display. This is great for presenting. So when you go out and scan a job, clients, sometimes they don't look at point cloud like we do. But if you show them a point shading point cloud, it's still a point cloud, by the way, just let you know, they'll get it, right? It's look exactly how it is in the future. And then on the right-hand side, you can see is the X-ray, which is still a great way for visualization, especially for planning, for architectural, engineering. The engineer sits in his office and you give him this data set, right? That's a lot of data. It's a lot of information, but you can show them some X-ray view and they can get a broad perspective on what the area looks like. So very good way to display information to people that don't understand point cloud, and like also great for presentation too as well. Here's just an interior picture. Now this tool, I want to remind you, it's not something that you have to add, right? So if you're a user of RIEGL, particularly RISCAN Pro, only RISCAN Pro, this tool, once we update it, it's included, it's free, right? So you can generate this, there's no cost. And yeah, it's just for all of our user and everybody gets it. Yeah. Okay, now let's move on to the tree analyzer. We've added this plugin. We've had so many, well, over the past 5 years, myself have been supporting the forest industry directly, particularly to universities, right? So there's been a big push for forestry, right, for carbon emission or for a vegetation growth, or for animal migration out in Africa, whatever the case is. So we've been a lot of demands, really, it's demands for vegetation and particularly forestry. So we recently introduced a plugin directly into RIEGL Control. Of course, this plugin has a fee, so please, if you want interested, contact your representative in your region, and we'll offer demos if it's necessary. But yeah, so this plugins allow us to identify trees automatically based on the 3D point cloud, right? And when I say automatically, I really do mean automatically, right? Because who has time and the patience to go there and identify all the trees? But I'm going to show you here in a little bit, really cool stuff. Yeah, so forestry inventory, and also complementing UAV LiDAR too as well. So in the past, right, so there's different platforms for different applications, right? So if you want to map out 1,000 square hectare or 1,000 acres, of course, you're gonna have to use an airborne system. But if you want to do just maybe 20 acres, maybe an unmanned system makes sense. But now, if you want to get into the detail plotting, right? So 100 meter by 100 meters, you know, where there's 50 by 50 meters plots of forestry, TLS is the sensor for that application, because we provide, the TLS system provide tremendous amount of detail, enough detail from the LiDAR and also from the photogrammetry to identify tree species, and also much more accurate volumetric calculation from tree stumps all the way up to the canopy. Yeah, so there's different platforms, but more importantly, within our software products, from ALS, kinematic to static, we can data fusion, we can merge the data together within our same platform. So you fly over an area with an unmanned system, you scan a plot, you can match that together pretty much automatically using plane-to-plane surface matching. But more importantly, it gives you a very comprehensive data set, right? So you have the top of the canopy, you have the base of the tree, you also have the ground too, of course, right? So sometimes you have buildup and vegetation droppage from the ground. Yeah, so and combining data from different platforms to give you a very comprehensive data set. And right now, a lot of cities are also want to know their tree inventories, right? So they want to know the health of it, they want to know how many trees they have, the growth, so they can do that for planning, they can do that for budgeting, because they have to replace trees, or maybe this right here is not getting enough nutrients or water. So whatever it is, it's a lot of demand for tree for forestry application, whether you're in an urban environment or also in a non-urban environment for carbon studies and whatnot. Yeah. Okay, so if you go on our website, if you want to take a look at this RFQ code, more welcome to just take your phone and go ahead and shoot it real quick, and it'll open up to our brochure, right? So this thing gives you all the information what our tool does, and of course, what it shows you and doing it's two different things, right? So it looks great, but when you do it, oh my gosh, it'll blow your socks out of the water. Maybe because it's automated and it really detects all those trees. And what's great about this thing is that you can define, because trees, it's very dynamic, big trees, small trees. So you can define the parameters of the type of trees or the size of the plant you want to find, and it'll find that, right? And then you go ahead and copy that into another space, and you open up the parameter and increase the parameter, and it'll find bigger trees, copy that over to another space. Or you want to find smaller tree, put a smaller diameter parameter in there and define smaller. So it's a very dynamic tool. It's not just, hey, I can only define this type of size trees in this height, right? So it's really user defined. Same thing with our system earlier. I really emphasize that our system is 100% user defined, meaning that you're not just set to, hey, these pre-programmed parameters. Use it to whatever size you want. Okay, so yep, please check us out. More information on our website for this tree analyzer tool. So if you're in vegetation, I highly recommend you take a look at this. Yeah, and of course, acquisition is also big too as well. So what you put in is what you get out, right? So you can't just go into a forest and take 1 or 2 scans, right? You're taking, you know, up to 50 scans or more, so right, depending on how thick the forest is and how thick the vegetation is, you may have to scan up to 100 scan precision, but it doesn't matter because what I'm going to show you here shortly, scanning is not going to be a problem, right? You're going to see why here shortly. Yeah, so we always wanted to define the scanner. Of course, the scanner is line of sight, so in order to see that part of the tree, you'll have to scan it. You don't have to get 360 degrees, just let you know that. You don't have to get 360 degrees, but as long as you have up to 80% of the tree, or even 75%, it's able to detect that tree and its diameter, height, and canopy, and it will then index it as an individual tree amongst all the other trees, color coded, and it also gives you a lot of information on that tree too as well, right? So of course, there's also a workflow too as well. So you can't just, you know, take this data set and throw it into the software and it work, because, you know, although this tool is sophisticated and smart and is automated, you have to clean it up, right? So you have to clean up the noise, and the more noise you clean up, the better analytical data that you're going to get out of it, right? It makes sense. And it's just like transportation, right? So you can't, you know, when you register, you got to register to control, and it's got to be deltas, right, from the X, Y, and Z value, just like this, right? So you got to clean it up. But nevertheless, our software cleans up our data completely automated, right? So a couple of key filters that you must apply, of course, deviation filters and reflectance filters. Okay, why are those things important? Because of the multiple returns capability and the laser wavelength that our scanner uses. When it passes through an object that you have 2 objects that are close to each other, it creates, we call it, I guess, ghost points, right? You've seen that, right? You scan something, you look at an edge of an object, there's points flying off the object, only if the object's close. Well, in forestry, everything is close. What I mean by that is that your canopy, your trees, your leaves, your branches, they're all right there. You know, it's very clustered. But our software can remove the points between the leaves and the branches by using simply a deviation filter. We call it a pulse shape deviation, because we log the outgoing pulse and we log the incoming pulse. We compare the 2 pulse, and the difference between the 2 is called pulse shape deviation. We can filter all that out and remove all flying ghost points. Yep. And then reflectance filter, right? So you're going to have different reflectivity based on the angle of incidence. So although our reflectance is calibrated, but not 180 degrees. So when the scanner looks at an object at a shallow angle, that there's a number of degrees that the reflectance is not calibrated, right? Because the laser pulse, right? The laser, the shape of it has changed too drastically, right? So instead of when it exits at a perfectly diameter circle beam, and when it hits at a shallow angle object, the beam then becomes an elongated ellipsoid. So therefore, produces a much different reflectivity and of course deviation value. So you got to clean up your thing. And we have workflow for all this too as well. Okay, so earlier I said data acquisition would not be a problem. Now I want to please let you know that we don't offer a backpack scanner. I know my colleague is walking with the scanner. It's because the scanner, it has a mobile feature, right? So it's a mobile scanner too as well. It's like a hybrid system. Now, I'm gonna have to do a presentation on this because I don't want to get the wrong impression that it is a mobile system, right? It's a terrestrial system, first and foremost, yeah? But it also has an option for mobile application. And I'm not saying, hey, go drive down the highway at, you know, highway speed, 50 miles per hour or 80 kilometers an hour and collect it. No, it's not meant for that. It's meant for slow speed, you know, maybe 25 miles or less. And it's RTK, right? So it's RTK and it's not PPK. Maybe that implement later. But yes, so we can walk and scan at the same time. Of course, we don't sell the backpack. Not that I'm aware of at least, but something that I think most of us are capable enough to make a backpack, right, and put the scanner on the back, right? You can't carry it, right, because the thing rotates. So, and there's two modes. There's radar mode. I really like this because this is, I'll play it again. Yeah, so right now it's in radar mode, but you can also put it on a fixed line mode too as well. So that line mode is going to give you very, very good point density, and it's like a terrestrial scan when you're doing line mode. But for such applications like this, it is best in most applications if you want to use the mobile 360 degrees radar mode. Okay, so after you collect the data, you clean it up, you throw it into our software, and you can see all the information and the trees and the trajectory of the colleague passing through, in an index, and it categorize all the trees in different color too as well. Now it also separates the tree from the ground. Now you can say, hey, does it do classification? We don't call it classification, right? Because it's, we're not intending it to be a true classification. But if you wanted to separate the ground from the vegetation, we can do that, right? And of course, I'll explain that in another PowerPoint. But yeah, let's go ahead and take some more analytical information that this tree analyzer can provide. You can see from the plot of the stock area, right? So on the left-hand side, we'll start with just a grayscale point cloud. And then on the right-hand side, we can then view it in a normalized height, right? So we can say, hey, 0 is here, and then 100 is up here. So you can then highlight the tree according to color. And then the selection of the trees to extract, right? So it does it automatically. It selects the tree. And it also, not just the base of the tree, but also the canopy too as well. And then on the bottom right hand side, you can see those are all the attributes of that specific tree and all the individual tree within that area. Now, if it didn't select the tree, of course, you can also isolate it, adjust the parameters, and then run it through the analyzer tool again. Again, this is a plugin. It's not a standard tool in our software. Now, please contact your respective representative to get more information on it too as well. You can see here, just give some example. We've been displaying this example a lot. It's because we want to bench test everything. And I remember I talked about productivity, right? So I remember I started working at RIEGL almost 16 years ago. It would take us, let's just say, 10 minutes to collect one position of data, right? And it would, and let's say by the end of the day, you have 50 scan position, which was true, 15 years ago, it probably took a day just to collect 15 scan positions, but it also took 3 days to process the data. And that was, it didn't make sense. It made sense back then because computer processing was slow, and we didn't have the proper algorithm. So it was a lot of manual adjustments and stuff like that. But now, the computer processing power is caught up. Our hardware technology, right now it's at top notch, and computers right there. So now we're really developing software to really complement the speed of the scanner, right? So we want to go from a 1-to-1 ratio, meaning that you collect 1 day of work, it should take you, 1 day or less, most likely less, to give you a deliverable. And I don't mean just, hey, register the point. No, I mean clean it up, filter it out, colorize it, georeference it down to server control, and then spit it out to the designer, the engineers, or the surveyor, whoever is needed. That's what I mean by processing. I don't mean just looking at the point cloud. No, sir. You can see here, and I'll do more of this later on. I'll do this your bench testing this, because why have a fast scanner if you can't really, give us some values to it, right? So I can say, hey, I got a fast scanner. But I can show you some more stuff on speed and productivity a little bit later, okay? All right, so let's move on to our ongoing development. And I think right now, this system that I saw 2 years ago, it was there. The idea was great, but I thought it wasn't ready. But now it certainly is. And that's what happens, right? So when this thing was introduced, the concept's great, and it worked. It worked to an extent. But now, it's being applied and tested in the real world. It's called the VMR. It's dedicated for rail. When we first introduced it, we wanted to make it rail because, rail around the world, not so much in America, but when you go to Europe, rail everywhere, or in Asia, But you know, we have states out here that do still, you know, like New York and stuff like that. They still use rail transportation. I live in Florida, not so much rail. Of course, just for cargo moving and stuff like that. But now with this new rail system, we're able to automatically, when I say automatic, right? So the rail system has something called ROS, right? So robotic operating system, which is a standard operating system for all robotics, right? So we implement that into our hardware so that you can then program the rail system to say, hey, travel at 10 meters, stop, take a scan, and if there's a target, scan in that target so you can tie it down to that specific coordinate system or location, right? And it's completely automated because the scanner can be automated, right? So the scanner has a bunch of apps you can see on there. One of them app, if you have a scanner, it'll be a VMR app, right? So you can scan, program your parameter for the lateral portion, and then program your VMR system for the moving portion, right? So you can say, hey, move 10 meters, stop, take a scan, move 10 meters, stop, take a scan, do it to 500 meters. You go ahead and click start, and all you have to do is just watch it at that point and monitor it, right? So, but not only it works on the rail system, we also introduce all-terrain wheels too as well, right? So if you're surveying in an area where there is surface for wheels, of course, this is also a nice feature too as well. And it's also either program or remote control, right? So this remote control is nothing unique. It's, you know, it's just controller, but it's an option, right? So all of our system, we have module kind of thing, right? So you can add the wheels, you can add the controller, or you just want to do rail. That's just the standard, right? So you want to add different options. We have different type of options for this, right? Yeah, so this is a remote control, and we're also introducing an app too as well. So if you're familiar with the VZ, the RIEGL iSeries app on the App Store or Android Store, you can download it, and that's just to operate the scanner. But now we also will introduce an app for our VMR for mission planning, right? So like I said, set it and forget it kind of thing. All right. Yeah, so here's just some more examples, some projects, some real-world projects that we've done. This one's in Vienna. And of course, I'll present something to United States once we get ours, and then I'll do some projects too as well. So I'll have a very good presentation coming later on this year. And if there's anything you want, please send us some comments and some requests. I have no problem presenting whereas application or how-tos. I love how-tos, right? So yeah, here you can see highlighted target, right? So you don't have to say, hey, scan, because our scanner can detect targets automatically, right? So on the scanner, in the workflow, you just define the type of target you're using, whether it's a cylindrical target or a flat target, or now, of course, the black and white checkerboard, checker pattern target. Yeah, it'll stop, and if it's a target within this range, it'll scan and pick it up automatically. Yep. Here is a live action shot of the robot. Sorry, the VMR. I guess it is a robot, right? I mean, you program it, it just does what it needs to do. Yeah, of course. Below that, there's just some emergency lights you see for safety precautions. So it's scanning right now. So this is still in static mode. We haven't done any testing in the kinematic mode, right? Because with the static mode, of course, you get the detail you're looking for, right? Because in the mobile mode, you may not get the detail because you're moving, right? So you're gonna have a little bit more noise on the static scan. Nothing beats static quality. But I'm sure you can go both, right? You can have this thing just keep on moving and scan at the same time. So if you don't need the detail, like look at the bolts or the condition or of the rail, then you can go ahead and make a description. But this system, I can see the application for like interchange, right? So railway interchange or areas that needs maintenance or rail yards, right? So you have a lot of trains coming in for docking and switching rails. Yeah, but we also have dedicated for train system too as well, that you mount on top of the train, and as you're scanning, it's a mobile scanner, but for rail, right? Okay, and this is the data quality that you can expect from the setup. And what you're viewing here is the shaded view too as well. So you can see it's a very good way to present and showcase and display. This is black and white. So not only we can collect the data automatically, we can also it also register the data. This is in true color, right? And this is at night. Of course, we have lights, right? So camera systems are passive sensors and LiDARs are active sensors, right? So that's inevitable. You're going to always need some light source at night, and you can go to your local photography store and buy those ring lights, put at the base or at the top, right? So okay, all right. So now let's get into some application stuff, right? So I've been concentrating on transportation for the last almost 15 years, or 16 years rather, right? And I've always liked transportation because I think there's been a paradigm shift on how data is collected now. So the old traditional way is very respected, guarantee, right? So you do a backside, you turn the corner, you figure out your azimuth, and that's never gonna be replaced, never. But there certainly is a paradigm shift on how data is collected, though, right? We think about it now, we're using sophisticated machines, 3D LiDAR systems, like the 600i or the 400i. So we're trying to expand the capability of terrestrial LiDAR in transportation. So when I first started, when you're doing a transportation project, it's always just a small scale. It really is. Because you couldn't cover long sections in a day, or in 2 days, or even 3 days. It may take a whole week, and by that point, you're just trying to cover 3 miles. It's not really something that you want to do with a system that's not productive, right? And then you have to look at registration, right? And you also have to look at survey control too as well, because when you're doing a linear project, you're going to have you're going to have a lot of errors, right? Error can introduce to the control, to the registration. But now with the capability of the 600i, and when I say capability, I'm just going to highlight just a couple things, okay? Because it has many capabilities. So just a couple things I want to highlight. One is the onboard registration. When I say onboard, it's true onboard. The scanner has 2 computers. One is dedicated for the scanning mechanism, and the other one's dedicated for the onboard registration and other post-processing too as well. So the second computer will automatically register the data together completely without the use of any targets, right? As long as you have sufficient overlap, it'll register the data together. And what's more importantly is that our programmers have done a fantastic job of extending these parameters to register in rural environments. And why do I want to say that in such a tone, right? Because cloud-to-cloud registration really requires vertical structure. But when you're in a rural environment, when you're in a grass field, when you're down a rural highway, where there's nothing but farmland, you don't have vertical structure. But in the past years, our engineers and programmers have really made that happen with our processing capability. Now we can say definitely we can cover 3 miles in a rural environment and be very successful, and more importantly, within a few hours of scanning. And I've done some bench testing myself, so and it is capable. So now projects 3 miles, 5 miles, I won't even bat an eye to go tackle that project. Yep. And then also increase project size, right? So I was talking earlier, 2 to 8 kilometers, no problem. And I've done this all summer, so I'll show you my next slide. I've done a lot of scanning this summer. I had so much fun with the 600i. And it's amazing how, you know, I've seen all the generation and working with terrestrial lidar for 15 year, and I'm still really blown away with the 600i. And sure, I could be a little biased, but it really is an incredible system, and I highly recommend you check it out. Now, and then safety, right? So I've always want to emphasize safety because it's like, hey, how does this terrestrial scanner, you know, makes me feel safe? Think about it. If it takes you 25 seconds for a scan, literally 25 seconds, and it takes images at the same time, you're out of harm's way, right? I mean, the more away from the road where traffic's driving by, vehicles driving by, highway speed or, you know, whatever speed, you're less chance of getting hit by a vehicle, right? So you push the button, you walk away, 25 seconds, you move on, right? So you get your job done quicker. You're out of you're off the highway quicker. You're more efficient, more effective, and more importantly, more productive in a very safe way. All right. So here's my summer projects, right? So I've done a lot of projects. I've done a lot of scanning because I didn't want to log everything. So I went ahead and just categorized 3 different types of environment: urban environment, transportation, indoor. Yeah, of course, I didn't scan every day in the summer. If I did, my numbers would be huge, right? But these are important that I've done personally, that I'm able to share directly. Yeah, so in urban environment, with all the projects I've done, 466 scan position, a total of 520 minutes, right? So you divide by 60 hours, whatnot. Transportation on linear road project, I'm not talking about intersection, I'm talking about, you know, projects that are 5,000 feet or more, or 2 kilometers or more. I covered 243 scan position. Now, I've done a lot more, but I only wanted to include projects that were like, you know, down control, or if I did a demo for the Department of Transportation, I can't share that data, but I can share you the numbers, right? So these are linear, just only linear project, 243 scan position, covering 3.3 kilometer, and 390 minutes. Okay, so you can go ahead and log those numbers and break it down, but don't worry, I've done it for you. Indoor projects, 502 scan position in 568 minutes. You can see it's almost a 1-to-1 ratio right here. But now, total of 1,211 scan position. So I pushed that start button 1,211 times. And it took me 4 hours and 4.6 hours, which is 1478 minutes. So breaking that down even further, I can safely say at each scan position, it's only costing me 1 minute and 26 seconds. And now that is not just pushing start, that is picking it up and moving it. By the way, picking it up now, I'm glad this system has come out to my time. I'm getting older, so I don't have the stamina and stuff anymore. So it weighs 13 pounds, you know, and we also include a compact tripod too that weighs an extra 5 pounds. So the whole system weighs, you know, less than 20 pounds. It feels even lighter than that. I think I'm getting stronger. The system's getting lighter. I think the system's getting lighter for sure. But yeah, so those are real world numbers you can definitely expect from using the VZ600i. So please stay tuned, and also please visit our next upcoming webinar on MLS value and efficiency, because everybody wants to talk about return on investments, and I have those metrics too as well. So if you want to contact me for some return on investment on terrestrial laser scanning, let me know. But yeah, please tune in next week on October 7th at 11 a.m. Eastern time, value and efficiency. So my colleague's going to talk about and share some return on investment information that's very compelling stuff that you can expect from some of our flagship mobile system and single head system, and also highlight some airborne stuff too with my colleague Michael Sitar on October 19th, same time, 11 o'clock Eastern time, and some new developments. So you're an airborne customer, and if you're, you know, interested, please tune in for that. And then last but not least, my colleague Claudio will have a presentation similar to mine, but in Spanish. And I wish I spoke Spanish, but then I would give it myself, but I don't. So thank you everybody for your kind attention. I hope that was some good updates. And if you haven't checked out the VZ600i, please do. You will not be disappointed. It is the future of terrestrial laser scanning. Thank you. All right. So we'll take a moment to get some questions if you have them. Is that correct, Andrea? Are we doing questions? Because I always seem to go over. And she typed, you know what? I'll answer questions anyways. So I'll go ahead and look at my dashboard question. Boom. All right. Gonzalez say Elisa's okay. Hello, Tan. Cloudy, but at least it's not 100. Oh, the rain stopped. I'll give it a moment for to type some questions. If not, I'm with RIEGL USA, and I look forward to any feedback, advice, questions, or recommendation for my next presentation. So, okay, I don't see anything coming in. If I miss it, I apologize, but sometime this platform is not. Oh, okay. Oh, I see questions. Hang on. Okay. Will the black and white targets work with the VZ400i as well, or only with the 600i? Now, from my understanding, so although we released the next generation of Terrestrial Laser Scanner, don't worry, our 400i have the same technology as the 600i. Of course, the 600i is more improved. So I would say yes, but I'm not 100% sure. But I will say yes, most likely, because everything I can do on the 600i, I can also do on the 400i too as well. So, but if you want me to follow up with confirm answer, I will. Just ping me and I will confirm that for you. But in my opinion, I would say yes. Okay. Let me see. Will you be giving a webinar on integrating with mobile? Yes, of course. Yes. I will. I will give a webinar on the mobile feature. In fact, I am working on a couple projects right now for that particular webinar. So yeah, stay tuned. I will give you a very good mobile webinar on the VZ600i. You know what? I'll do it on 400i too as well, because I know a lot of customers also have the 400i. And don't worry, we don't leave those customers behind. So that feature is actually on the 400i too as well. So if you don't know, if you have a 400i, it does have a mobile capability, but please contact your respective distributor representative, because you do need a firmware update, and you also need the external RIEGL GNSS RTK receiver. Okay, so you have to have RTK, and the correction has to come from a VRS N-trip network. So you can't do it from base, you gotta do it from a network. But I will explain more about that and how we can get away with RTK and the internal IMU on my next webinar on how we can achieve the accuracy and precision and from the 400i and also 600i and mobile mode. Yep. So thank you for that. All right. Let me see. Will the data VZ600i penetrate? No, the VZ600i cannot penetrate water. We do have systems that can penetrate water, but those are going to be in the green laser spectrum, right? So the VZ600i, 400i, all of our terrestrial laser line, except for one scanner, I'm not going to name because nobody really uses it. Sorry, I didn't mean about that. I mean, like, you know, it's really made for just scientific research. There's a VZ6000i, right? So that one has a little bit more powerful laser. But no, all of our terrestrial laser, most of them, 99.9% of them are in the 1550 nanometer, 1.5 micron near invisible beam red laser. So no, it cannot penetrate water. Sorry about that. But we do have systems that can penetrate water for unmanned helicopter or high altitude airplanes. All right. Let me see what else. I can never see the questions. I can only see one question at one time. So, and I'm trying to scroll to find more questions. I saw a question about, okay, I guess I meant using the TLS data to, yes. Can I use the TLS data to constrain MLS? Absolutely. We have customers that have our mobile system, and then also buys a terrestrial system for such application, right? So yeah, so you can doing a corridor mapping of 100 miles, right? Yeah, you can scan in certain strategic areas where you have high control. You register the terrestrial scan to your control, and then you can constrain the data down to control. So within our platform, right? So if you're using RIEGL and RIEGL Pro, you can bring the data back and forth very easily because it reads the same native language, right? So we use RDBX file. You can bring it into RIEGL Pro, or you can RIEGL Pro, bring it into RIEGL. I'm not an expert in RIEGL, but for a fact in RIEGL Pro, you can definitely do it. All right, let me see. How can we acquire a testing model? How can we acquire a testing model? I'm not sure about that question. What do you mean by how do you acquire a testing model? Like a demo? If that's your question, a demo, yeah, contact your respective representative within your area. If you're in the United States, you got to call me. Yeah, so if you mean by testing model demos, we offer that for sure. All right, let me see what else. Scan time for the same setting on a 400. Okay, on a 400. Okay, hopefully you forgot the eye, but if you're talking about 400, 6mm resolution at 10 meters on a 600i takes 25 seconds. On a 400 eye takes 45 seconds, but on a 400 it takes 3 minutes. 3 minutes. Okay. But if you're using a 400i, if you love it, upgrade to 600i, you'll fall in love all over again. I promise you that. All right. Oh, 400i, 45 seconds. No, that's panorama 60. It's 0. Oh, so that'll be, sorry, it'll be approximately 1 minute and 6 seconds. Yeah, yeah, for 6mm. Sorry, when I say 45 seconds, that was panorama 60. Panorama 0.06. That's not the same thing as 6mm. 6mm is 0.04, I think. So, okay. All right. All right, I think I'm running out of time. I always do. Thank you very much for your attention. I look forward to your feedback, your calls, and happy scanning. Good luck out there. And until next time, cheers.